Hi, I'm Sarah Murnen, a professor of psychology at Kenyon College. I'm going to talk today about how to conduct a chi-square test of independence using SPSS. First, I'm going to show you a PowerPoint that describes the data I'll be using. Okay, and in this example, I'm going to talk about a data set we've been collecting to look at children's characters, dominance and submissiveness in children's characters. So a little bit of background. Although societal roles for women and men have changed since the second wave of the women's movement, gender stereotypes are still very commonly portrayed in the media. And it's believed that this is in part due to a backlash against women's accomplishments in the workplace. There might be an increased emphasis on stereotypes that support the power imbalance that still does remain in society. So in the present study, we wanted to look at cultural products that are available for girls and boys to see the extent to which they're gender stereotyped. We looked at Halloween costumes, we looked at dolls and action figures, and we looked at Valentine cards. And we coded the extent to which these characters that are represented have characteristics associated with dominance and submissiveness. I'm only showing you a portion of the data here. Our hypotheses are that submissiveness cues will occur more often with female characters than male characters, and that dominance cues will occur more often with male characters than female characters. It's a little more complicated than that. Again, I'm only showing you a portion of the data, but notice here, this is a costume for a girl, and it's a Monster High costume. If you don't know what Monster High is, it's a doll that's available. There are also Valentine's cards, costumes, and you can see that it's a little bit sexualized. That's something else we are looking at that I won't cover here. But also her body positioning is somewhat submissive. She's not standing straight and tall. Her spine is somewhat curved. Her head is canted. Those are all submissiveness features. In contrast, we see this Halloween costume for a boy, and certainly he looks more powerful than this character does. And there are a number of things here that are related to dominance. Things like standing tall, being somewhat in motion, but there's a whole bunch of things going on here. But again, we're only going to look at a portion of the things that we coded. So we did code a lot of these characters that we collected in 2013. Now, how do we determine what means submission, what means dominance? Well, we're using research that other people have conducted to come up with our definition. And some of this goes back to the work of Irving Goffman, a sociologist, who examined gender inequality in advertisements defined by occupational role, body positioning, use of touch, facial expression. We also expanded the dominance definition with some more recent research that looks at what people call hypermasculinity, that there's such an emphasis on violent masculinity that different cues are represented than was true when Goffman did his work. So I'm just going to show you a few cues here. Body in motion is a dominant characteristic, whereas showing the body with a curved spine is submissive. Actually, those Monster High dolls do have a curved spine. Functional clothing is a dominant characteristic, like a uniform is a very functional piece of clothing, whereas clothing could be merely decorative, just, designed for you to look at the person, not to think that they're ready to do some, kind of powerful action. And then I'll also show you a hypermasculine cue of having a weapon present. Now with the chi-square test of independence, what we're looking at is when we have two variables that are both qualitative that we want to relate to one another. Qualitative means if you assign numbers to the characteristics of the values of the variable, the numbers don't have a meaning. They're just used to distinguish different categories. So one variable here is the gender of the character, which we're going to code as 1 for female or 2 for male. And it's arbitrary, like which is 1 and which is 2. These are just numbers that are used to distinguish the different categories of a qualitative variable or of a categorical variable. The other variable that will relate to the gender of the character is whether or not the cue occurred. And we're going to code 0 as the cue did not occur and 1 that cue did occur. I could also have used 1 versus 2. Again, those numbers are not that meaningful when it's a qualitative variable. So what I'm going to do here is conduct, different, a total of, I guess 5, I can't remember how many characteristics, different chi-square tests, just in case you're interested in the data. So separate tests conducted to see if the pattern of whether or not the cue occurred varied by the gender of the character. Okay, I'm going to show you the SPSS file next, before revealing the data. Okay, this is my SPSS data file. Again, I'm only showing you a portion of the data, and this is the variable view part. Notice that I did put value labels on my variables. I like to do that so I know what the values mean. So for gender, 1 means female and 2 means male. And then I'm going to show you data for body and motion, the way I've coded that. 0 means no, the characteristic did not occur with that particular character, or yes it did, value of 1, etc. Let's look at the actual data so you can see the data in columns. I have a subject number. I say what type. Remember, they could be costumes, dolls, action figures, Valentines, the gender, the name, and then the different cues. Again, the full data set is bigger. To conduct the chi-square test of independence, I go to Analyze, and it's under Descriptive Statistics, and it's crosstabs. It doesn't sound like chi-square, but that's where you do it, crosstabs. And what you do is indicate what variable you want to relate to what other variable. So let's do gender and body and motion. Now, for this particular test, there are some pieces of information I want to make sure that it gives me. First of all, under statistics, I want to ask for the chi-square value to be printed out. In the cells, what it's going to do is show you the frequencies that have been observed, like how many female characteristics are shown not in motion. Got a code of 0 for the motion. How many got the code of 1 that they were shown in motion. By the way, there's a whole, lot of work we needed to do to establish the reliability of our coding for this, because you have to be a very good observer to look at these and see what means motion and what doesn't. And then somebody else has to be able to use that coding and agree with you that that did indicate motion or not. So there's a lot that goes into this type of coding in terms of reliability and validity. So it automatically is going to show you the observed frequencies, but I also want to look at the percentages. That's information I want. I'm going to talk about expected frequencies when I look at the output, because what the chi-square is doing is it's going to generate a set of expected frequencies that we would get if there was no association between these variables. And it takes the observed frequencies, compares them to the expected frequencies. And the chi-square statistic is the observed minus the expected squared over the expected for each cell in the design, and then you add that up. So if there's a big discrepancy between what you observed and what you expect, if there is no association, you're going to get a very big chi-square value that will be statistically significant. But I'll come back to that. And I don't want the expected frequencies. Actually, okay, let's see what that gives us. Okay, now I'm ready to do the test. So first of all, it's going to just show you the frequencies and the percentages. So here's what we observed. These are female characters, the body and motion. So of the 223 female characters, 174 of them were shown to be not in motion in how they're depicted, whereas 49 were shown in motion. Now, those observed frequencies are not that interpretable. I like to look at the percentages. So basically 78% of the female characters were shown not to be in motion. Only 22% were shown in motion. Compared to the male characters, let's look at the percentages, 38% or 39% not in motion versus 61% yes, they were in motion. Now here's the logic of the chi-square. Let's look down here. So across gender, looking at the totals, slightly more than half of the characters are shown not to be in motion. About 41% are shown in motion. Now, if there's no association between gender and showing the body in motion, what you expect is that this same pattern should occur for both the female characters and the male characters, but what you see is a discrepancy between the observed frequencies, and here's what the expected frequencies would be if there was no association. You'd have slightly more shown to be not in motion for both the female characters and the male characters, but that's not what we find. We find that male characters are shown more often in motion, which is a dominant characteristic. Let's look at the actual value of the chi-square to see if there's a statistically significant association between gender of the character and body in motion. Okay, here's the value. We're going to look at the Pearson chi-square value. The degrees of freedom associated with chi-square, for a lot of our tests that are parametric, that rely on assumptions being met for the data, we have interval level data for the dependent variable. Our degrees of freedom are based on sample size. But here, it's a much simpler test. We're looking at categories here, and the degrees of freedom are based on the number of rows that you have, -1, times the number of columns that you have, -1. Since we only have 2 rows, 2 columns, the degrees of freedom are 1. Here's the value, and the probability of that is less than 0.001. Remember, no such thing as a probability of 0, but since it's only to 3 decimal points, we want to say probability less than 0.001. Now, what does that chi-square mean? Remember, that's going to be a bigger value if there's a discrepancy between what we actually observed in our frequencies and what we would expect to get if there was no association. So there is a statistically significant association. To interpret it, go back and look at the pattern. Male characters were more likely to be shown in motion than female characters. So let's go ahead and look at the other characteristics in case you're interested. I'm going to go back to Analyze, Descriptive Statistics, Crosstabs. And basically, I can ask for all the rest of them in one command. I guess it was more than 5 here. And it'll do all these tests. You might not be interested in all of them, but let's just run through them. What you see is a pattern of, very strong stereotyping here. So here's the curved spine data. So first of all, that's a pretty big chi-square value, statistically significant. When we go to look at the data, most characters across gender are shown not to have a curved spine. When you look at the males, almost none of them, only 4 of them are shown that way. When you look at the females, that's a very different picture. Almost half, 46%, are shown with a curved spine, which is a submissiveness characteristic. Friendly facial expression. Women, that's significant. And female characters, I don't want to say women because these are not generally women. They're girls or Minnie Mouse or some female character. So female characters, 66% shown with a friendly facial expression versus only 17% of the male characters. Instead, it was more common to show the male characters. First of all, you often couldn't see their expression because it was hidden behind a mask. But here these are the data on angry. It didn't occur that often for the male characters, 16% of the time, but it almost never occurred for the female characters, 2% of the time. Again, a significant chi-square. Not quite as large because this is not something that occurred that often, thankfully. The decorative clothing, 88% of the female characters were shown in decorative clothing, whereas only 12% of the male characters were. Very statistically significant. A chi-square with 1 degree of freedom equals 253.33, probability less than 0.001. In contrast, functional clothing, I shouldn't say in contrast because these are not mutually exclusive. Something could be both functional and decorative. It didn't occur that often, but it could. So functional clothing, 78% of the male characters are shown in something very functional like a uniform compared to 13% of the female characters. The chi-square is definitely significant. probability less than 0.001. And then finally, this was one of the hypermasculine cues that we were interested in. Goffman didn't look at these because there wasn't such a depiction of hypermasculinity when he did his work, but we see that the presence of a weapon occurred in about half of the male characterizations: Halloween costumes, Valentine's cards, action figures. We use the pictures that were on the websites, by the way, and of the most popular. And then hardly ever occurred for females. So, statistically significant, probability less than 0.001. So what we see is that these are very stereotyped. Now we are, continuing to analyze these data. And one thing that we do see is that the Halloween costumes are a little less stereotyped than the Valentine's cards or the dolls and action figures, which makes sense because it's actual children who are depicted. And you wouldn't expect necessarily to see a child with their hand in a fist representing hypermasculinity, although actually it did occur. So this is the Chi-square test of independence. And again, what it's doing is looking at whether this pattern that you see here across gender of having a weapon or not, about 73% don't have a weapon. Do you see that same pattern occurring for the female data and the male data? No, you don't. And when you compare the observed frequencies to the expected frequencies, you are getting a discrepancy. And to actually compute the chi-square value, if you wanted to do it by hand, you take the observed value minus the expected squared over the expected. You do that for each cell and you add it up across these 4 cells to get your chi-square. So the bigger the discrepancy between observed and expected, the larger the chi-square value. Thank you for your attention.